Everybody, here is your bell ringer for the day. So make sure you get yourself a bell ringer sheet and work through these on your bell ringer sheet, and then we'll go through the solutions in a little bit. So please pause the video, have the students work through these, and then I'll go through the solutions, or you can press play again in a couple minutes. So for the first one here, we're just solving for x here. So you want to just kind of multiply what you can. So we got the 4 distributing into there, and the -3, the sign goes with it, distributes into there. So we want to do that first to just kind of get rid of those parentheses. We've got an 8x minus 8 and a -3x minus 21 equals -4. So then we simplify stuff on the left there. So we got an 8x minus 3x, 5x, and then we have a -8 and a -21, so that gives me a -29 equals -4. Add 29 to both sides. So we want to get the x by itself, so let's isolate the variable. 5x equals a 25. Divide both sides by 5. And then we are finished because 25 divided by 5 is 5. If you wanted to, you can check your solutions by plugging that back into the original. Okay, but we'll save some time and we'll just say that it works. So number 2 here, this stuff is from back in the day when we were doing standard form. So remember standard form, we got ax plus by equals c. So we don't really care about the a, b, and c. We just need to have x and y on the same side, and then there's no fractions, and the number in front's got to be negative. So that means the 6 has to move to the left, and the 2 has to move to the right. So our first step will be moving those. So we'll have a -6x minus 3y equals a -2. And then I said the a, or that number in front, has to be positive, so we can multiply by a -1 and switch all of our signs. So we'll get 6x plus 3y equals a +2. That is the standard form of the equation. Okay? Slope-intercept form, remember that's y equals mx plus b. So the x is on the right and the y-intercept is on the right. So if we go back up to our original equation up here, we have the y on the left already, but that 2 needs to move over, and then we're going to have to divide everything by a -3. So if we move the 2 over, -2 minus 2, we'll get -3x equals 6x minus 2. Remember, we always want the x first. And then we'll divide everything in the equation by a -3. And then we can just rewrite it. Oops, I wrote an x there. That should be a -3y. So those will cancel out. We get a y equals -2x plus 2/3. That doesn't really break down much. It's just a fraction there. Okay, so if we were to graph this, 2/3 is my y-intercept, and the -2 inside there is my slope. All right, so that's your bell ringer. If you guys haven't had the chance to look at your tests yet, you'll get those passed out here, and then you can look at your scores. Take about 5-6 minutes to look at your test scores, look and see what you did incorrectly, and then turn those back into the basket, and we'll start with the new notes for 6-1. Okay, so take some time to do that. Okay, so back at it, we're starting 6-1. So this is chapter 6, and this is where we start to throw a lot more variables at you. So we're kind of using everything that we've done before in one problem. Okay, so we're going to be able to find domains. So remember, domains are x values. X values, we're going to be able to find domains of rational functions, and we'll figure out what rational functions are here in a minute. We're going to simplify rational functions, multiply rational functions, and divide rational functions. Okay? So looking at what rational functions are, or rational expressions. Okay? So a rational expression is an expression of the form p over q, where p and q are both polynomials, and q cannot equal 0. Okay? So something really simple to compare this to would be 1 over x. That would be a rational function. Okay, so most of the time when you have variables in the denominator, that's called a rational function. Okay? I've said it a couple times in class, in passing. When you get variables in the denominator, that's a rational function. So then we're taking the next step here, and we're finding our domains of rational functions. Okay, to find the domain of a rational function, you got to look at what it cannot be by looking in the denominator. Okay, so this is where we're going to look. We're going to look in the denominator and figure out what it cannot be. Most of the time, it's all real numbers except for something. Okay, so it'll be everything except for x cannot be something. So for this one up here, this would be all real numbers, but x cannot be 0. Because if I put a 0 down there, think of what's going to happen. If you put 1 divided by 0 in your calculator, you're going to get an error. It says cannot divide by 0 in all capitals. Okay? So let's take a look at what one of these would look like and how we find its domain. All right, so first one here. We have x squared divided by x squared minus 9. So go ahead and write that down if you haven't, and then we'll figure out how to do it. So looking at the bottom here, we got x squared minus 9. That's what we're going to look at. That's how we're going to figure out the domain of the function. So you could think about what numbers I would plug in for x to get a 0. All right? A better way to do that is you just take the denominator, that x squared minus 9, and set it equal to 0 and solve. Okay? We did a lot of that stuff just in the last chapter. We had 5, 8, 5, 7, and 5, 6. Those last 3 sections of chapter 5, we were doing the x squared minus 9 equals 0. We were factoring that and solving that. That's essentially what we're doing here. Okay? So let's take this, x squared minus 9 equals 0, and let's figure out what we can plug in to make it a 0. All right? So you got to remember our patterns. This is actually a pattern because 9 is a perfect square. Okay, so 9 is a perfect square. So that means this is going to split up to x minus 3, x plus 3. That's difference of squares pattern. Okay, that's one that I told you guys that you have to remember. All right, so if I have x minus 3 and x plus 3, both of them equal to 0, how do I figure out what my solutions are going to be here? I got x minus 3 equals 0 and x plus 3 equals 0. So those are going to give me x equals 3 and negative 3. So the 3 and negative 3 are the numbers that I cannot plug into the denominator here. I can't plug those in because they're going to give me a 0. All right? So I have to use these to make a statement about the domain. So domain, we write it like this, and we'll just do set notation. Okay, so domain, we're looking at x values such that x cannot be 3 and x cannot be negative 3. So that would imply we have everything except for those two values. All right, and that is how we would write our domain for this function. Okay, another way that you could write it, which I've had my Algebra 2 students do, I say it's all real numbers, x cannot be positive or negative 3. That's a little simpler way to do it, but if we're looking for set notation and the way you're going to see the answers in the textbook, the one in the box up there is the way you would do it. So that's how we find our domain for that one. So for the next one here, what I want you guys to do is try to factor the bottom and then see if you can get your solutions, and then we'll write the domain out together, okay? So pause the video for about a minute or two, let kids factor out the bottom, and then start it back up for the example. So if I don't want to take the time to rewrite everything, I'm just going to look here right away and factor it on the bottom, all right? So we got to think of two numbers that multiply to give us 12 and add to give us a 1. So factors of 12 would be 1 and 12, 3 and 4, 6 and 2. Okay, which of those three factors can either add or subtract to give us a negative 1? That would be the 3 and the 4. Okay, we want x minus 4, x plus 3. Because if I have a negative 4 plus 3, that gives me the negative 1 in the center that I'm looking for. Okay? So I factored it out. Now we have to take the time to set both of those equal to 0 and solve. All right, so this one's going to give me x equals 4. This one's going to give me x equals negative 3. So remember when we actually do that, those are the values that I would plug into my denominator to get a 0. And we don't want a 0. Okay? So these are the numbers, the 4 and the negative 3 are numbers that cannot be in the domain. So domain, okay, set of all x such that x cannot be a 4 and x cannot be or cannot equal negative 3. So that is what I would have for the domain of this rational function. So hopefully you guys are seeing how we don't really forget about the stuff that we just did in the last chapter. We're using it again here. So we're factoring and solving, but that's going to tell us numbers that we cannot have in our domain. Okay? I think that's the last example here. All right, so the next step would be simplifying. Okay, so we're simplifying rational expressions, and all of the stuff that we're working on today, we're going to be factoring. Okay, so hopefully we just had the test over factoring, so we should all be fairly decent at it. If you are still having problems with factoring, then you're going to have to figure it out because this entire chapter involves factoring. So what I see a lot of kids do with these is they're like, oh, I have an x there and an x squared in the front, so let's just cancel one of those out and we'll have an x there and that's gone. That's not the way you want to do that. Okay, don't do that. That's the number one thing that I see go wrong with these. All right, so I just said that we're going to have to factor. So that's the first thing you want to do. Always start with factoring as much as you can. Whenever we see an x squared and an x in a problem, that means you can factor something. Okay, so let's take the top and let's factor that. So two numbers that multiply to give me 18 and add to give me a 3. All right, so we got 18 and 1, 9 and 2, 6 and 3. Hey, that's the one. So x there, 6 and 3. If we're looking to get a positive, or a negative 3, excuse me, that means we're going to have a negative 6, positive 3. So this stuff is what I have in the numerator. So let's tack the denominator back down there. Now, when you simplify these, you have to cancel entire factors. So if you need to, you can list the bottom in parentheses like that, just so it looks like something familiar, or it looks like something on the top. So I'm looking between top and bottom here. Do I have the same factors that I can cancel out? Yeah, I got an x minus 6 there and an x minus 6 there. That's the only thing that can cancel. So x plus 3 is the factor that is left. That's our solution, or that's our simplified expression. Okay? So factor, and then you can kind of get cancel happy and start looking around to see if you can cancel some factors. Don't just cancel single numbers or digits unless there are single numbers or digits on the bottom. Let's try this one. Okay? There's a little trick that we're going to have to do with this one. So we're going to do this one together because there is a cubic on the top, and you have a cubes pattern that you have to use. So hopefully you didn't forget about that either, because that was just on the last test as well. Okay, so we're going to factor the top one again. I'm just going to kind of rewrite my work down here below. Since we have a cube, remember that's the SOAP pattern stuff. We got the little set of parentheses and the big one. And we're figuring out what times itself 3 times will give me that. So that would be a 3x. And then we're figuring out what times itself 3 times will give me that. That's a 2. Okay, so that's my little parentheses. So we're going to have 3x minus 2. Now, remember my pattern. I took this one. When I put it in the front here, I squared it. And then I took the back one, and I put it all the way in the back, and I squared it. And then the middle term here for my third term was 3x times a 2. All right, so we're going to have our signs will be same as what we started with, opposite of that first sign, and then always positive on the back end. So that's what we have for our SOAP pattern. Now looking at the bottom here, it doesn't really look like you can factor anything. All right, so let's write it down below there, 2 minus 3x. Okay, looking between the numerator and denominator, and I'll put that in parentheses just so it might look a little bit like something on the top. Do you have anything that can cancel out? Do you got a 2 minus 3x on the top? Well, no. but I do have something close. I got this, which is a -2 and a +3. So there's a little trick to these, okay? Remember I told you guys before, if we have a negative variable like that, then you want to make it positive most of the time. So we want to factor out a -1. Okay, so if I factor out a -1 from this, factor out a -1, that would look like this. -1 in front, and then that's just going to switch around what I have in that parentheses. Okay, so see here, before that was a -3x, now down here it's a +3x, and you always want to write the x first. Okay, so now if you look between the top and the bottom, we got the 3x minus 2 will cancel out. And then we have the 9x squared plus 6x plus 4 left. So we have that on top in the numerator, that in the denominator. So remember, when you are dividing by a -1, it just switches all your signs. So it would be -9x squared minus 6x minus 4. And that is all. So we started by factoring whatever we could. Okay, and then we saw this on the bottom, that if we just flipped our signs, we'd have something to cancel out. So we factored out a -1 to do that, and canceled what we had, and then just simplified in the end. Okay, so that's simplifying rational expressions. The next thing here is multiplying rational expressions. Okay, so we're going to start out with something like this. This is fairly easy. So think about how we multiply fractions. So say we had 1/2 times 1/2. Hopefully we should know how to do this. You multiply straight across, and you would get 1/4 for this one. Okay? That's one way you can do this. You can multiply straight across, but then you kind of simplify in the end. Let's think if we had 1/2 times 4/3. Okay? Well, you can still just go straight across and simplify in the end, or you can cross cancel first. So if I look at the diagonals here, these the 2 and the 4, can I cross cancel something? Yeah, I can take a 2 out. So this would turn into a 1, and that would turn into a 2. And then I multiply straight across. So 1 times 2 is a 2. 1 times 3 is a 3. So we would have 2/3. Okay? So those are the two options that you have. Same kind of rules apply with rational expressions. Okay? So what I like to do with these rational expressions here and here, these two rational expressions when we're multiplying them, I just kind of simplify the numbers in front if I can. So I'm going to look here, 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 and here, and then cross cancel if I can. Okay? So 4 and the 8 will cross cancel. That would give me a 1, and that would give me a 2. And then the 2 and 7 don't do anything. Okay, so let's multiply it straight across now. And if some of you guys are looking at the 2/2, you can actually simplify that as well. But we'll just save that for the end. So I'm going to go straight across, multiply straight across here. So 2 times 7 is going to give me a 14. And then x cubed times x to the 4th, we add the exponents, we'll have x to the 7th. And then y times y cubed is going to give me y to the 4th. Then on the bottom, 2 times 1 is a 2. X times, we don't have another x over there, so let's just tack it on. And y squared times y is a y cubed. Okay? Now that's not your answer, because that's not in simplest form. You have x's on both the top and the bottom, and y's on both top and the bottom, and we got a 14 and a 2, so those can all simplify. So the next step here would be kind of simplifying it down. All right? So 14/2, these ones, that simplifies to a 7. And then remember what we do when we have variables here. When you have division of variables, you subtract the exponents. So that's like a 7 minus 1. That's going to give me x to the 6. And then here, y to the 4th over y to the 3rd. Oops, that's going to give me just a y. That is your answer. That's your simplest form answer here. Okay? So start off by simplifying the coefficients on those, and then multiply straight across to get this, and then we simplify one more time to get our final answer. Okay, we'll do one more of these together, and then we'll have you try one on your own. So number 6 here, this is where we have a handful of variables floating around. So these are binomials and trinomials. So remember, with binomials and trinomials, we're probably going to be factoring. The last one here, we didn't really have to factor because there were no pluses and minuses or anything like that. They're just monomials in the numerator and denominator, and you just kind of go across and simplify. So for here, let's rewrite this after we factor. So this one right here, you can't really do anything. All right, so we're just going to rewrite that. It's all kind of nice. We can't factor anything out because we got a 4 and a 5 up there, so there's no terms in common. This one right here, we can do a little bit of factoring. So in the top, we have to factor the x squared minus 12x plus 36. So two numbers that multiply to give you 36 and add to give you 12. That's 6 and 6. So we'll have x minus 6, x minus 6. On the bottom, that's that little trick that I just showed you a little bit ago. The x is negative, so think about how to get the x positive. What are you going to factor out? Well, we'll factor out a -1, and it'll switch everything around. So -1 comes out, and then we're going to have 4x minus 5. And then the same rules apply here. When you're multiplying these, you can cross-cancel, or you can kind of just think of, since I'm multiplying straight across, all my factors will kind of be multiplied together like this. And then I can just try to cancel stuff from top to bottom. So in the bottom I got an x minus 6, in the top I got an x minus 6. Okay, and then I also have a 4x minus 5 here and here. So those all cancel out, and I'm left with x minus 6 over -1, which we can simplify that down by dividing everything in the top by a -1, so I'll have negative x plus 6. That would be my solution. Okay, so again, steps are factor everything completely. So we factored everything up here completely, and then we multiplied straight across and canceled factors out. All right, let's try another one. So I want you guys to try to factor this one on your own. There were some of these on the review guide, some of the x squared, y squareds that we just had on the review guide in chapter 5.8, 5.7. So we should have an idea of how to do them because we just did them not long ago. Okay, and we're actually going to have to factor here and in the other one. Okay, so pause the video, have students try to work on this. They can ask questions together, see if they can factor it out and cancel stuff. All right, so give them about 2 or 3 minutes to give it a shot, and then we'll come back to the video. Okay, so this one right here, we factored that out. So if we look on the top, we can't really factor anything, so I kind of take my words back there. We got an x squared minus 2y, it doesn't really factor out. Okay, so let's just rewrite that one the way it is. X squared minus 2y over x minus y. That one stays the same. Now this one, we can factor stuff out. Okay, so the numerator here, it's going to be SMILE method on the top and the bottom. Okay, so since we have a 2 in front, we're going to have a 2x and an x, sorry, a 2x squared, and then we got a y squared in the back, so that means we're going to have a y and a y in the back. So when we multiply those, so 2xy, and then we're going to have xy. I want to get a -1 in the middle, so that means my 2 has to be negative and my 1 has to be positive. So that's how we factor the top. And then the bottom is going to be pretty similar to that. You're just going to have different signs in there. So we're going to have a 2x and an x, and we're going to have a y and a y. And this bottom one's actually easier because everything is positive. So that means all my signs are positive. All right? So now we're looking straight across here. So we're multiplying these things. So let's just kind of add parentheses here. Got my numerator and my denominator since we're going straight across. And let's start canceling things out. So I got an x minus y down here. I also got one up here. I got a 2x plus y here and here, so those are going to cancel. So the only thing I have left would be x squared minus 2y over x plus y. That is it. You can't go any more from there because the top doesn't factor and the bottom doesn't really factor anymore. Like again, what I've seen people do is they take the x's here and they cancel one out, and you might want to cancel a y out here, but you don't want to do that, okay? Because the plus on the bottom and the minus on top don't let you do that. Whenever there's a plus or a minus splitting things up, you can't just cancel pieces of it. So this is your final answer. So let's look at division. We'll try a couple of these, and then you can work on your homework. Okay, so I want you guys to factor everything completely. You should be able to factor this and rewrite it. Okay, so pause the video, have students factor this when they are all ready to factor, or when they're ready, or when they're done factoring, excuse me, then play the video and I'll show them how to finish it out. Okay, so this one, we can factor that one a little bit. The top stays at the 7x. The bottom, we get a 2x minus 10. So 2 and 10 are both divisible by 2. So we're taking out a 2. So we have 2 parentheses x minus 5. And then divided by, factor the one up here. So this one on top, we got an x in both terms. So let's take those out. And then on the bottom, we are going to factor this out. So two numbers that multiply to give you 30, positive 30, and add to give us 11. So that's 6 and 5. They're both going to be negative. So x minus 6, x minus 5. Okay? So think about how we divide fractions. So if we got a 1/2 divided by a 1/2, so we are going to skip the first one, flip the second one, and multiply. You should remember that from middle school. If you went to the middle school here in town, they teach you skip, flip, multiply. That's how you do division of fraction. So this right here would turn into 1/2 times 2 over 1. And then you're multiplying fractions, which we just did that for the last 3 examples. So you cross cancel, and we get a 1 over 1, which is just 1. Okay, so let's apply that idea to this one over here, to the polynomial, the rational expressions. So we skip the first one. All right, so we just rewrite it, and then we flip the second one. So x minus 6 over x minus 5, and then x times x minus 6, and then we multiply. Okay, so since we're multiplying, we're kind of just going straight across. So I got an x minus 5 that's going to cancel there. I got an x minus 6 that's going to cancel there. And now we have this x in front, and we have just an x right there. So those are actually going to cancel out too, because those are like single factors. Those are monomials that are out in the front, okay? So those x's will cancel. And all of our variables and everything canceled out, so we just have 7 over 2. And that doesn't simplify anymore, so that will be our solution. So this stuff right here is a fancy way just to get 7 over 2, which is 3.5. All right? So factor everything like we did before, and then you skip, flip, multiply. So pretty much the only addition, or only the change from multiplication to division, is you got to flip the second one. All right? Which you can flip it before you factor if you want to. It doesn't really matter. So I want you guys to try this one now. So please pause the video and have the students see if they can get this one, and then restart, and I will go through the solution. All right, so looking at this one on the left, factor the stuff on the top. So we got an a squared and an a on the top, so we're going to be able to factor that probably. Okay, so 6 factors or possibilities are 6 and 1 and 3 and 2. So let's try the might actually try the 3 and 2 here. So 3a and 2a. And then the back one, we're going to have a 2 and a 1. So if we put a 2 there and a 1 there, and then we check our smile, so that would be a 3 and a 4. Can we use that to get a -7? Yeah, they both got to be negative. Okay, so that's what the top factors out to. And then the denominator, that just stays as a 5a. There is no factoring involved for monomials. Okay? And then this one, we got to flip it. Okay, we got to flip that thing. So let me do that quick. So 2a squared plus 2a is going to be on the top, and the bottom would be 3a squared plus a minus 2. So that's our new polynomial that we're going to factor, our rational expression. So on the top, we can take out a 2a. So that would be taking a 2a from here and here. So that's going to be giving me an a plus 1, right? Because if we think of taking out a 2a from both of those, it's the same as dividing it by a 2a. Okay, because some people might think that that just goes away. It actually turns into a 1. And then our denominator here, we got a 3a and an a, because that's the front number, 3 and 1. And we got a 2 in the back number, or the back there. So we're going to have a 2 and a 1. So think about where I'm going to put the 2 and the 1. If I put a 2 there, I'd have a 6 and a 1, which is not going to get me the 1 in the middle. So the 2 goes here, and then the 1 goes there. Okay, if we check that, that would give me 3a and 2a, which I can put those together to get a 1. So I want a positive 3 and a negative 2, like that. So that's how we factor the denominator, or the new denominator rather. So we skipped the first one, we flipped the second one, we factored, now we're going to multiply. So let's just go straight across. So we have a 3a minus 2 there, 3a minus 2 there. We got an a plus 1 there, a plus 1 there. And then we actually have a floating around there and there, so we can get rid of those. And then we just rewrite what we're left with. So we have a 2, and then a 2a minus 1 over 5. And I'm okay with you guys leaving this like it is. It actually looks a little bit better if I would distribute that 2. So I would have 4a squared minus 2 over 5. That actually looks a lot more clean than the other one does. So if you want to, you can take it that last half a step. All right? So that is all for the lesson. So this is all rational expressions. And this is really where we're taking another step in the difficulty level here, because there are a lot of variables in all these problems. Okay? So if you need help with this video, I will put it in Google Classroom so you can watch it again. And you can also look up videos on YouTube, such as simplifying rational expressions. Okay, so that's this here. So you can check that out if you need some help. Khan Academy is pretty good with this stuff. There's Yay Math, that's another YouTube channel that's pretty good. That guy's got a lot of energy, so maybe some of you will appreciate that video a little bit better than this one. So good luck on the homework. Let me know if you got any questions.